You are saying you want to understand the naming of organic compounds better. You also want to understand how you also want to understand organic reactions. So this is what's gonna happen. We're gonna talk about the naming a bit, what to look out for during the naming and things like that. Um, before we go far, let's first do this. Um, I'm gonna give you a few minutes. Actually, pause the video, write these notes down. Okay, just write them down. As once you're done, then we can resume. No, So I assumed you paused the video. Or you just unpaused the video. I assume you are done writing these down. Now let's go back to what we were doing. Mm-hmm. I hope you've written all those things down. Okay. Let's talk about what are organic compounds. What are organic compounds? When you talk about when we talk about organic compounds, we are talking about compounds that consist of carbon. This element called carbon has up to 4 bonds and forms covalent bonds, usually with hydrogen. This is like carbon. If you check the group of carbon, it's number 12 on the periodic. No, it's not number 12, is it? No, it's molar mass is 12, yes, but it's not number 12. But then if you check on your periodic table there where it stands on the fourth group. So it has four things, 4 bonds, those lines and things like that. I wouldn't say whether it's positive or negative because of that. Noble gas has 8 valence electrons. Carbon, on the other hand, has 4 and whatnot, whatnot. Example, your DNA. Your DNA is an organic compound because it consists of carbon. Hexane is organic because it consists of carbons, as well as your ethanol. These ones, they sound familiar. I'm sure you're familiar with all of them here, but you must be familiar a lot with, especially things like ethanol, hexane, and all these things. You must be familiar with them because you are studying, right? I hope you didn't just jump up and say, okay, give me some answers for the test and whatnot, because you want to understand it better. It's not your first time. Yeah, maybe you're in class and didn't hear a thing. So let's talk about what they are and things like that in terms of naming. But I'm not gonna be as slow with this as I am gonna be on reactions. Okay, this one I'm just gonna be quick. Okay, naming of organic compounds. You've got your first ones, which are your alkanes. Your alkanes. You've got your alkenes, and you've got your alkynes. Listen to the words there: alkane, kene, kyne. Right? This is your single bond, double bond, and your triple bonds. These ones are your hydrocarbons. They consist of only carbon and hydrogen. Okay. Then let's go to your haloalkanes. Your alkyl halides, alkyl. The moment you see this part, "-ile", you must be thinking of something like a side chain. Your methyl, ethyl, propyl, yeah, ethyl, ethanoate, there's that ethyl, which means this is a side thing. Okay, this is a side thing. Um, your haloalkanes, halo from halogens, or your alkyl halides. Remember, halides, these are your fluoride, chloride, and your bromide. They are single bonds, yes, like hydrocarbons, but they consist of halogen, a halogen, your bromide or your chloride or your fluoride. You get what I'm saying? It doesn't matter how many, but as long as you see a halogen, this is a haloalkane. Listen to this, haloalkane. This is still that alkane. The only thing that changes is that here now we've got halo. We've got halo, or you've got your halides as your alkyls. You see, they're still alkanes. The only difference is with where you're supposed to be having your hydrogens. In this case, you may be having 1 or 2 halogens. Then you've got your ketones, which is a double bond oxygen. It's bonded to a carbon, but not on the first carbon. Maybe second carbon, third carbon, fourth carbon. It doesn't matter. It depends on what it is, what type of ketone this is. Maybe this is your ketone. This is your, mm, you know, methone. Yeah, 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 ketone. The O-N-E, that's your suffix, and things like that, like your ethone. Yes, your ethone. you know, your prop 2 owner, you know, but 3 owner, you know, or 3 buton, something like that, you know, which means it's on the third carbon, which is quite impossible because you are numbering from with butyl, it can't be on number 3, that's number 2. Yeah, maybe with penton, that's where you'll find it on number 3 because now there are 5. Yes, yes. With the penton, it can be on, no, it's gonna be what? 1, 2, 3. 1, 2, 3. Yes, yes. With your penton and things like that. Then your aldehydes. Now, be careful of something here. Aldehydes and ketones, they are similar. The only difference is that these are your functional isomers. Your ketones, the double bond oxygen is in the carbon that is bonded to 2 or more other carbons. Your aldehyde, the double bond oxygen is only bonded on 1 carbon, which must be your first carbon. Okay, your first carbon. All right. Then you've got your alcohols. The moment you see OH, the moment you see something like OH, that's when you know that, okay, this is a game changer. We are now dealing with alcohols. The moment you see something like OH, that's when you know that, okay, now we are dealing with alcohols, okay? Carboxylic acids. Carboxylic acids. This one, you need a carbonyl, which is your C, double bonded to O, double bond oxygen, and a single bond of OH. These ones end with COOH, like your ethanoic acid, CH3COOH. That's your vinegar, you know, and things like that. You can have methanoic acid, propanoic acid, nonanoic acid, decanoic acid, octanoic acid. It's all up to you. You can have whatever that you want. It can even have a side chain. It's up to you. But what's important is that this one, then you've got your esters. Oh, please don't mind the spelling. The H is not there. Yeah, just assume the H is not there. Okay, for esters. You've got your esters, which is a combination of alcohol and a carboxylic acid. Okay, this one has the COO and then C. The COO comes from your carboxylic acid, and then the other C comes from your alcohol, which has to do with the naming of an ester as well, but mostly having to do with the formation of an ester. And we are getting to it. I couldn't get the pictures. I don't know what's wrong. You can put, but then, you know, you can write your own structural things, whatever that you want to write for alkanes, you can write maybe ethane, you know, ethene, and all those, okay? Blend them and things like that. Let's go to functional groups. What are functional groups? You've got your hydrocarbons, which have to do with thing. Remember, we haven't gotten to reactions yet. Right now, we're still on the naming part, so that you understand the naming better. Hydrocarbons. These ones are single bond C, CH3 or CH4s and all that. But you'll never find CH4 unless it's methane. Other than that, when it comes to ethane and all that, you won't find CH4. Your hydrocarbons, you know, your ethenes, your ethynes and all those, you know, alkynes. And then you've got your halogens. Halogen works as a functional group because a halogen tells you that this is a haloalkane or alkyl halide. You see, when the moment you see something like 2-chlorobutane or something like 2,3-chlorobutane or 2-bromo 3-chlorobutane. You see what I did there? 2-bromo 3-chlorobutane. You see, you start with the bromo because B comes before C, you know, A, B, C, and all that, right? You know, at the moment you see halogen, you know that, okay, this is your haloalkane or your alkyl halide. Then there's a carbonyl, which is C double bonded to O. A carbonyl, you know, you're expecting something like this. When you talk about your carbonyl, you're expecting something like this. Something like this, you know. Yeah, something like this. This is what you call a carbonyl. Carbonyl. This one we call it a carbonyl. C double bonded to O. Now realize something here that your C being bonded to O double, of course, it's gonna have 2 other legs to stand on. You know, at least it has a leg to stand. You know, yeah. It's gonna have 2 other legs to stand on. It can be bonded to hydrogens, of course. Over here, it can be bonded to oxygen if it wants to. Why not? And your hydrogen, you know, this is where this is not a carbonyl. What's this now? Oh my word, oh my word. Okay, get out of here, get out of here. Yeah, this is not okay. Get out of here. Yeah, COOH, or you can have it as just your age, you know. But this is your carbonyl, which you usually find from ketones. You know, instead of putting H here, they can put R to say, okay, this stands for anything, you know. As I showed you that here it can be OH or it can be just your H. It's all up to you. It depends on what they're asking. Even the examiner can decide whatever they want to decide. But you've got your carbonyl, which is this. Then you've got your hydroxide, the hydroxide, which is your OH. That's your hydroxide, okay? Now let's talk about the carboxyl. Carboxyl, okay, carboxyl. You've got the same thing. The carboxyl, which is R, as I told you, R, it can mean anything. I mean, it means anything can stand there. CO, but then this is where the difference comes in. Now, the difference is that now, this case, we've got, the difference is that now we've got OH. So this is CO and then OH. That's your carboxyl. R can be C, whatnot, whatnot, whatnot. It doesn't matter. Or it can be whatever that can be there. But for you, it's going to be C, you know, unless you're trying to, or H. It can be H. Yes, it can be H. Then this is your methanoic acid. Methanoic acid, you know, COOH with another H. Now, watch something here. Watch something here. One, be careful of something here. These are two. This is a double bond. This is a double bond. Okay, this is a double bond. Carbon, these are two, and it must have four. So you've got your three there, then you've got your four there. There, it's complete. You know, one, two, three, and then four. It's complete. Your carbon is complete. You can't bond anything with it again. You can't bond with anything again. Okay, that's your carboxyl group. Let's go further. Let's go further. Let's talk about the naming. The naming. Uh, let's talk about the naming. The naming. You've got 2,4. Realize something here. You start with the position of the side chain because we want to end what the actual name is. We want to end with the name that tells us what we are naming in the first place. We want to end with that, you know, and things like that. We don't start with that first and then no, no, no. We end with it. 2,4. These must be in ascending order. That's the first thing that you must check. Second thing, the side chain that comes here, the first alphabet of it must be the first alphabet of all side chains. You know, for example, E comes before M, right? Be careful of this now. This is 2,4 diether. Don't look at di and say D comes before M. Please, please. The diatrite and all that simply indicates how many of those side chains you are having. But what's important there is the side chain, ethyl, ethyl, you know, which means your side chain there is an ethyl. But because there are two, you're going to say diethyl. But ethyl is going to come before methyl because E comes before M. So before you consider this di, consider the main side chain. After considering the main side chain, the side chain itself, then you can consider how many they are. There are two, so you're going to say di. What are their positions? 2 and 4, right? So 2,4 dash diethyl dash 3, another dash. On number 3, we've got a methyl, okay? Yes, if we had something like 3,5, it was going to be dimethyl again, or 3,5,8, it was going to be trimethyl. And you go on like that and like that, okay? Then we get to the actual name, but the suffix of the name must come last. In between the suffix and the thingy, your prefix, like your octane, your ethane, and all those things. You know, like for example, let's say it's an ethane. You know, between those, your eth, your prop, your but, and all that. You must have the position of the functional group. It is preferred to be in between so that you know when you read the name, you can clearly see where your functional group is located. In this case, oct, which means there are 8, octane, and then 1 of, which means your functional group all tells, the suffix all tells you that it's an alcohol. One tells you that the functional group of the alcohol is on carbon number 1. Now, you know your functional group is the atoms, you know, bond of atoms, or a molecule that tells you what type of an organic compound this is. In this case, this is an alcohol. You can see it by the hydroxyl group. That's why you're going to end it with all. You see, just like that. You must make sure that it's like this. Those notes that you read there after pausing the video and whatnot, they will help you throughout. Okay. And I hope you wrote them. I know someone here you will say, no, you don't need those notes and whatnot. I hope you wrote them down. Just have to make it simple, but continue studying from your textbook as well, please, because your textbook, you first need it in more detail before you can have it in that type of detail. Now, remember, this is for you to understand it better. I'm not starting the whole thing from scratch, okay? Reactions of organic compounds. Let's talk about the big thing now, the reactions. The reactions. Okay, so we just spoke about naming organic compounds, right? And now you are there like, okay, now I can name an organic compound. You can name it from a structural formula. When you have the name during the structural formula, you start with the longest chain, followed by your functional group. No, start with the functional group, continue your longest chain, then you will add your side chains afterwards, you know, unless you want to be a professional and I don't know, try to play around the location of your longest chain. Maybe carbon number 3 must go down, the number 4 on the side. It's all up to you. You can do that. It's up to you. You can make it in an S shape, you can make it like this, and then you say, okay, there I will have my side chains going down diagonally like that. It's all up to you, as long it is okay, it is correct. How a person comes and counts the longest chain is up to them really, but the longest chain is the longest chain and things like that. Okay, although I prefer you make it in a simpler way, because a person who marks and feels like, oh, this is too much work, that person might say you are wrong or might not count correctly and then say you are wrong. You know, first things first, with organic reactions, we mostly deal with hydrogen, water, and halogen. Okay, with reactions, right? Now I know something is missing here. You're wondering, but what about carboxylic acid? Because carboxylic acid has a carbonyl, which there's oxygen there. And here now I'm telling you that deal with water. I know water is H2O and all that, but your carbonyl group, we don't change it. In most cases, we use it for esterification. Okay, that's where you're gonna see it the most and things like that. Because remember now, going back to our things, we've got halogens, carbonyl. You see, so far we said we are dealing with the hydrocarbons, we're dealing with halogens, and we said we deal with oxygen. I mean, with water, which has to do with your hydroxide and whatnot. Then when you come to carboxyl, the carboxyl, this is where we deal with esterification, which is a game changer because esterification is unlike the uh, other thingies, unlike the other organic reactions. Okay, and things like that. Okay, now, all right. It is important to understand and be able to apply the laws of Markov, Nikov, and Zaitsev. Please learn them, know how to apply them. Markov, Nikov says when you remove, I'm going to say it in simple terms, okay? Don't write it in simple terms in your test. Write it exactly according to your textbook so that you pass at the end of the day. Because, you know, one of the reasons that I don't trust the teachers, they might say they want to do it for it and, you know, all those type of things. Another way is that, I mean, another reason is that, you know, sometimes there are some terms, scientific terms that are required from you, which if you don't include those terms, uh, you know, you're not going to get marks. Even I'm not going to give you marks, you know, so try to, yeah. So Markov, Nikov, and Zaitsev. Markov, Nikov says, when you add a hydrogen, you add to the carbon bonded with most hydrogens, you know, the rich get richer, as you said. And then Zaitsev says, the one who's poor, useless, just take away from him, you know. Yeah, when you remove hydrogen, remove and whatnot. But, you know, let's go deep so that you understand what I'm actually saying. Because right now, you can think all the gibberish you want to think, but Now let's go deeper, so that next time when you hear the word Markovnikov, you don't think gibberish. Careful of the, oh no, this thing gives me a problem. Let me use this one. Elimination. We've got three type of reactions. We've got elimination, we've got addition, and we've got substitution. Okay, this one I'm gonna take step by step. Okay, I'm gonna take it step by step. You now know how to name. Otherwise, go and watch again. Learn how to name structural formulae. Take them and write your own name from it. Like practice it, check from past papers whether you named it correct and things like that. You wrote those notes. Make sure to follow those notes. You have the idea of what a name should look like. I showed you with that alcohol, that octane one, or with your methyl and your diethyl. Use it, make sure your thing looks plus minus like that. And, yeah. Okay. D. First thing first, the moment you see D, it means we are eliminating D. I don't know what happened to the E here. Maybe my finger slipped or something, but D, you can all see the E, right? D, then it means elimination. D, yeah, D, what's this? De-acceleration, something like that. D. Now, dehydrogenation. Please, we are not removing water, okay? Don't get confused. And I know many matrix will get confused because they see the word hydro and they're thinking, oh, hydro. We are not removing water, please. We are not removing water. Hydrogenation. Now think of it this way. Let's say you were the one giving it a name. Ne? Now, to make it simple, hydrogenation is a matter of adding hydrogen. You see, hydrogen, and then hydrogenation. You're hydrogenating it. What's this now? No, 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 no. Yes, hydrogenation. Why will this be doing like that? Hydrogenation is a matter of we are adding, but this one is dehydrogenation, which means we are removing hydrogen. Note something, and please, if you must write this down somewhere, write it down where you wrote those notes. Okay. Hydrogen is a diatomic compound element. Okay, hydrogen H2. It's diatomic. I Brinkley for our new house. Your diatomic elements. Hydrogen is one of them. Please. Then you've got your dehydration. Most of you go to gym. I assume when you're in primary school, you used to go to gym. If you didn't go to gym, maybe in life orientation. If you hate life orientation, maybe in your TV shows. If you don't watch TV and you study, then I don't know. I don't know. But you get what I'm trying to say. Be fancy at school and say I'm dehydrated. Then, but hydration, this one now has to do with water. You always say this. I'm dehydrated. But when you come there, you say, okay, what type of reaction is this? And you can see that water is removed. You fail to say it's dehydrated. There's dehydration. No, please. The moment you see hydration, it's your normal hydration that you know of in your everyday lives. I'm hydrated, I'm dehydrated, and things like that. Why you drink water, you gotta stay hydrated. To study, you must stay hydrated. I'm giving you a tip now. As you're watching this video, I hope you are hydrated. Please make sure you are hydrated. If you're not hydrated, don't be afraid. Pause the video, go and be hydrated, then come back. Yeah, you wanna go and get some H2O in your, what do you call this thing? Or esophagus, something like that. Whatever. I didn't take the subject. Dehydrohalogenation. And I'm sure this is where your head, listen to the word. We've got DE, okay, we are eliminating something. Hydrogen. This hydro has to do with hydrogen. Halogenation, the halogen. Remember when I said, imagine you are the one creating these names. Halogenation, adding a halogen. So your dehalogenation is removing a halogen. Now we also have a hydrohalogenation, okay, which I'm going to explain just now before going to addition, okay? And then the last one is dehalogenation, removing halogen. Okay, fine. Now let's explain this issue of dehydrohalogenation, why it's like that. You've got your carbon. See, you've got something like this. Got something like this. No, 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 no. No, no, no. Actually, let's do it like this. No. Mm. No, 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 no. Actually, I don't. Okay, yeah, no, Br because chloride, the spelling of chloride confuses me a bit. So let's go with bromide. There's nothing wrong with chloride, okay? It's just the CH and the L sometimes H. Yeah, and yeah, no. Let's say you've got something like this. Let's say you've got something like this. Ne? And all around these carbons are your hydrogens, okay? Please, please, please. And I'm going to ask you again, please. When you draw structural formulae, do not forget to include hydrogens, okay? Do not forget to include hydrogens. You're not going to get marks if you don't include your hydrogens, okay? And that we are working against it. So do not forget. It's only that it's for the sake of your time and my time that I didn't include hydrogens here in this one, okay? Because oh, it's gonna take time, including hydrogens. But okay, it's fine. You've got something like this. And remember what I said now. I said I said your hydrogen is diatomic, right? But okay, forget about that for now. Ne? For now, forget about it. You've got something like this, and you say, I want this bromide out, this bromide out. And in this case, we're not gonna apply Zaitsev or Markovnikov yet because we are dealing with bromide, and bromide is not a hydrogen. When your bromide is out now, you're gonna come up with something like this. Let's act like you finally took your bro out. You know, yeah, you took your bro out. Ne? Nah, 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 that doesn't sound so right. You took your bromide out. Let me just say bromide. I know some of you when I say bro, you lose focus. So yeah, you took it out, right? And you have something like this. Now, this carbon is bonded with three hydrogens. Remember, carbon must be bonded with four things. This carbon is bonded with three hydrogens. This one is bonded. This one is also bonded with two hydrogens. This one is bonded with three hydrogens. Why? Because this one, the other two bonds, and then don't do me like this. Yo. Yes, yes. This one is because the other two bonds are bonded to the carbons, right? That's how it is. You took this bromide out for some reason. You took it out. Ne? The question is now, what now? Because this carbon must be bonded to four things. So far, it is bonded to two carbons. It is bonded to hydrogen. Then there's this extra leg there that we don't know what it's doing. Okay, we don't know. It must either bond with this carbon or that carbon, and we're gonna remove hydrogen. I'm gonna show you why. The question that you should be asking yourself, having drawn this structural formula, this is bonded to three hydrogens. Remember, this is CH3. I'm expecting to see CH2 here. I'm expecting CH3 here. Here, I'm expecting your H there at the top because your bromide was at the bottom. Or if your bromide was at the top, then I would expect your H at the bottom. It's all up to you. You know, I prefer putting it at the bottom. I don't know why. I just, my mind just loves it at the bottom. But then to look fancy, you're going to put it at the top. I know. Go ahead, but don't confuse yourself, okay? This one is bonded to three hydrogens, three H2s, ne? This one is bonded to two hydrogens. Markov-Nikov says when you add to the carbon with the most hydrogens bonded to it, when you add hydrogen. Zaitsev says when you remove hydrogen, remove to the carbon with less hydrogens attached to it, right? I'm just saying it in simple ways. Please don't go write this in your text, in your test, write what they're saying, but I don't think they're gonna ask you this. But you never know. These ones, I don't trust your teachers. They might ask this. I don't trust them. So yeah, we're gonna remove hydrogen from this carbon because it's bonded to only one hydrogen, while this one, no, to two hydrogens, while this one is bonded to three. We are not in grade one, so please don't ask me how three is more than two, okay? Or don't ask me how two is less than three, or something like this, two is two is less than three, something like that. But please, we don't do that here for now. And then from there, Br carries a negative charge while hydrogen carries a positive charge. So when they bond, you start with the positive one first, which is your H, and then the negative one, which is your Br. Remember with your, now let's do this, with your, what you call, OH. Yeah, somehow you started with oxygen there. Oh, I wonder why you started with oxygen. Oh, maybe because it's the one that gave away a charge or something. I don't know. And then H somehow became negative, somewhere like something like that. But HBr, ne? Your hydrogen bromide, right? Okay, fine. Relax, relax. Let's say as a student, you say, okay, now that I removed HBr, I want to challenge the teacher. Let's talk about addition. We want to add HCl in this case. We want to add HCl. No, HBr again. You say, no, let's put it back, and things like that. It's just like saying, you know, let's let's reconnect, we can try this again. But now when you try things again, ah, you get what I'm saying. When you try again, yeah, it might not work out the same way, but let's hope it works out. Now you've got HBr. Here you now have something like this. After having removed this thing, please follow along with what I'm saying so that you don't ask questions like, where does this one come from suddenly? No, you've got something like this. Mm, uh, with your carbon, then you've got your double bond carbon. Remember, this is CH3, and then C, there's your hydrogen there, then this is your CH3 again, right? This time around, you want to add HBr. You want to add HBr. When you add HBr, actually, you know what? Let me actually show you something. Yes, let me actually do this. Let me actually write the structural formula. Yeah, it's a structural formula, like that's professional chemistry. You've got your hydrogen there bonded with your bromide. Ah, come on, don't do this. What? Yeah, you've got your hydrogen bonded with bromide. The question is, where is the hydrogen going to go? Don't look at the bromide. Your bromide is not a halogen, okay? Hydrogen, okay? So don't look at the bromide first. Let's look at the hydrogen. CH3, draw it. Please draw this with your hydrogen so you don't get confused. CH, CH, and then you've got another CH and then CH. Uh-huh, ne? And things like that. So let's go deeper now. CH3, right? This is CH and CH, and then this is your CH. Ah, and then this is your CH, CH3, CH, CH, and then another CH3, right? Okay, fine. According to Markov-Nikov, because now we are adding, the rich must get richer and the poor must get poorer. I know you're gonna get confused and say, but this is CH and that is CH. Listen to me carefully now. It can go anywhere, absolutely anywhere. It can go anywhere. Your hydrogen can go to this one, and your bromide can go here, or your bromide here, and your hydrogen here. According to your notes about naming, you name from the functional group, which means whether your bromide is this side or this side, it will always be on number 2, right? Okay. Let's try and make a game changer here. Maybe if we make a game changer, maybe I'll succeed in this. Let me see. Let's try and add some carbons. Where's the problem here? Okay, let's try this. Let's try the no, it won't work like that. Ne? Let's see, it's still CH2, CH2. Okay, no, we'll try it somehow. But you see what I did there, ne? So yeah. Okay, let's say, oh, yeah, let's do this. Let's do this. Let's say this thing, it was like this, ne? And you wanted to add your H2O. You wanted to add water into this thing, right? You wanted to add water into this thing. Okay, fine. No, actually, let me be professional. Let me be professional. Mm, that's your H2O. You want to add H2O to this whole thing, and you wonder where one of the hydrogens is gonna go. Where one of the hydrogens is gonna go, right? Now remember what I said. Your hydrogen is still gonna go to the carbon. This is CH2, this is CH2. Your hydrogen will go to the carbon with the most things, hydrogens bonded to it. So it's gonna go, so it's gonna go there or there, it doesn't matter. Then your OH is gonna go to the one with least hydrogens because it's an OH. It's not a hydrogen. Okay, then you're gonna have something like this. You're gonna have something like a C, and then C with your C with your OH. Please don't write OH like this. Okay, you're gonna lose marks. Better write it down as your O, and then show your teachers that yeah, and things like that. 1, 2, 3, 4, 1, 2, yeah, 1, 2, 3, 4, 5, 2 plus 4, that's 2 plus 4, that's 6, né? And things like that. Okay, then you're gonna have something like this. But let's say you are now removing water. Let's say we are changing games now we want to remove water. You are now removing water. You are now removing water. Okay, you add hydrogen where you, okay, this one is the same because of the H there and the H there, right? Yeah, it's the same because you've got your CH and then you've got your CH 1, 2, 3, 4, 1, 2, 3, 4. You're pretty much gonna remove hydrogen from here, yes, right? Okay, now we'll go look for examples. We'll go look for examples. Yeah, let me go further. Let me go further because with this example, seems like the same thing is gonna happen. So yeah, then you've got hydrogenation. Hydrogenation, we are adding hydrogen. Hydration, we are adding water. You saw the Markov-Nikov and Zaitsev rules, how they work and things like that. Hydrohalogenations, don't get confused. You're adding a hydrogen with your halogen, and this is where they can get swapped depending on what's happening. This one usually adds to an alkene. You never add to an alkyne. You add to an alkene, which when you add, the rich get richer, but you're most likely to find CH, not CH2, and then you add where there's CH2. Although it can be possible, you can have your Br with you can have your bromide or chloride or fluoride on the first carbon, then when you remove, but when you add, realize something that the rich get richer. Okay, yes, this is actually something similar to what I'm looking for. Come on. This is similar to what I'm looking for. Yes, finally. So you've got your C with your ER, ne? It doesn't matter. Let's say you've got something like this. Now understand something here that there's another one of your hydrogens, and please add all the hydrogens and whatnot. Let's say you removed HBr here. You were doing a dehydrohalogenation because there's a halogen and there's a hydrogen, right? Let's say you were doing that here. Probably gonna, oh, okay, fine. You want yourself at, come on, right? You're gonna end up with something like C double, ah, like C double bond C with all your hydrogens and everything, right? Now you want to add your HBr again. In this case, your H is now gonna come here. This is where your H is gonna come in. And you probably wonder, what's happening? This is what you had, right? Let me do this. This is what you had. Ne? I mean, this is what you have now that you remove. And you want to add H again. Now, here your H was there and your BR was there, right? You removed and you had something like this. Now that you've got something like this, you want to add HBr again. Or you want to add water. You want to add water. And I think this is what I was trying there, but no. From an alkene, if you remove hydrogen and add water, okay, whatever. You want to add this thing again. Your hydrogen this time around is gonna come here because this is CH2. Remember, this is CH. What? Don't remember saying this thing can close. What's happening? Yes, you've got something like this, C, right? And you want to add HBr. Your H is gonna come here because this is CH2, this is CH. This one is bonded to one hydrogen, this one to two hydrogens. Your hydrogen is gonna come here, then your Br is now gonna come here. These are two things, they must be broken down. One for here, and then the other is for here. Because remember, this one leg comes from the one leg of each carbon. You know, it's something like this. Something like this. You see that there was this leg for this carbon, then that leg, and then these two, they came together to form that second. These two legs, whatever you call them, came together to form that one leg there in your CH2. That's what happened. So when this thing breaks down, it breaks down like that. Okay, fine. Don't know why this thing is behaving like this, but it is what it is. We're gonna go through a past paper so I can show you something about this thing. Then you've got your hydration. As I said, go and be hydrated. Then you've got your hydrohalogenation, hydro for hydrogen, and then genation, your halogenation right there, which is uh halogen. You know, so we are adding a hydrohalogen. Remember, H is positively charged. Your halogens are all negatively charged, so they can bond together. Then you've got your halogenation, which you're probably gonna add to an alkene or an alkyne. No, with an alkyne, you're gonna add, it's probably gonna be hydrohalogenation with your alkyne. No. With your alkyne, you're gonna add hydrogen, which is unusual. Substitution only occurs in the presence of a dilute catalyst. Your questions will say this reaction takes place, and then beyond the arrow, you're gonna find something like dilute sulfuric acid, or you're gonna find something like dilute sodium hydroxide, dilute potassium. No, not potassium. Is that potassium hydroxide? Yeah, I think so. Potassium is number one. It's next to lithium. Maybe lithium hydroxide. I've never found such a thing, but maybe lithium hydroxide. Usually sodium hydroxide, you know, because of your sodium chloride, sodium bromide, and your sodium fluoride. You know, I don't know why I can. But yeah, substitution only occurs in the presence of a dilute catalyst. Hydrolysis occurs when a catalyst consists of hydroxide, example, sodium hydroxide. The element that is bonded with the hydroxide will bond with the halogen present in the organic compound. Please note this. Note this. Let's say in your halogen, I mean, your alkyl halide or your uh, haloalkane, you've got maybe one bromo propane, right? One bromo to say, okay, this is an alkyl halide, and then, you know, because it's still an alkane, there are still bonds. One bromo propane. That bromide can bond with the sodium there. Then the hydroxide can still bond with that carbon, which it forms your alcohol, right? The substitution reaction, you will find out why I had to state that it only occurs in the presence of a dilute. Now, let me explain something about the dilute, and I'm not going to do some drawings because you saw what happened. Let's say you are drinking juice. Juice. You are in South Africa, so you know in South Africa our favorite juice is Oros. You know that. Yeah, OJ, or whatever you call it, Oros. You're drinking Oros. You can put too much of Oros that it sounds taste too sweet and whatnot. We say it's concentrated. If the Oros is less, there's more water than the Oros, you're gonna say it's diluted. That's why your parents, when they send you, they say make sure it's well diluted. But when you come to chemistry and you see the word dilute, you get lost. Like, what's happening now? No, no, no. It's still the same dilute. When you say dilute, you are saying there's more water than whatever that is. If you put your thingy, yeah, just like with your oils, even with your salt, when your water is salty, the salt is concentrated. There's a high concentration of salt, so it's salty. You're gonna say it's salty, I know, but this time around, say it's concentrated. But if you can't even taste that there's salt in it, I know some of you, when they ask you for tea, you're only gonna put 1 teaspoon of sugar because you're probably daydreaming about some weird stuff somewhere. And then your thingy, what you call, you're not gonna taste so much of the sugar. So then you say it's diluted because there's more water. You get what I'm saying? Someone came with an example that when you say it's concentrated, it's probably a rod, of the sulfuric acid, like a rod, and it needs water because it can absorb water. Think about your oils with less water. You need more water, otherwise it's too sweet. You get what I'm saying? And things like that. So now let's try to get a past paper quickly. Oh my word. Let's do this. Those of you who are still writing your notes, quickly write them down. Let me just look for your thing. Let's see. Just gonna look for the paper quickly. While I'm looking for the paper, I hope you're not going to drink water somewhere because I'm very thirsty. Or you wanna go and drink water, it's up to you. Go and drink water quickly, come back, and then we're gonna look at this. Okay, I hope you drink your water and things like that. Here's the past paper. Yeah, I know you can't see it yet. I will, oh, yeah. Okay, I hope now you can see it, no? You're still seeing the notes, right? If everything goes well. You're still seeing the notes. Now you can see the paper. All right, so let's first be professional chemist a bit. This is what your paper looks like. This is 2021. This is the paper. Oh, no, never mind. I will say, yeah. Question 4 is where you find your reactions. Okay, whatever. Yeah, just come up. Whatever. This is where you find your reactions, but they're not gonna draw the thingy, because they know grade 12s. They're not gonna draw your things in structural formulae and whatnot. Now watch this. Compound P is used as a starting reactant in each of the two reactions as shown in the flow diagram below. Okay, you've got your flow diagram 1, 2, and 3 represents what. Name the type reaction represented by 1. And I'm gonna show a specification like last. Okay. Dilute sodium hydroxide. Remember what I said. Okay, compound P, they are showing C5H11 bromide. Use your general formula, but think about it. If it was C5H10, it would have been your pentene, right? Because H10. And then because of the 2 hydrogens on the side, it was going to be C5H12, which would have been your pentane. But this time around, it's H11Br, so which means one of the hydrogens on the side. For your 2 CH3s, remember it's going to start with CH3 and end with CH3, right? Yeah, and then the rest, yeah. So your first CH3 is going to be CH3, but your second CH3 in this case, your last CH3 will be CH2Br in this case. Think about it. You can go ahead and draw it. You will see what I'm talking about. Your Br can be on one of the ones. It's up to you. And then there's a dilute. So which means there's more water than the sodium hydroxide here, right? There's a dilute. So because there's more water, there's space for substitution. So the type of reaction, the substitution is actually hydrolysis. Why? Because sodium hydroxide. So your sodium can bond with your bromide. It's fine, because your sodium is your positive charge, and positive always bonds with your negative charge. And then from there, your hydroxide is gonna go back to where it found the bromide, where the bromide was. So your hydroxide is gonna say, okay, I'm sitting with sodium. Sodium now found a new friend called bromide. Let me go and replace bromide. So sodium hydroxide will go back there, and then you're gonna have your C5H11OH. This is your 2-methyl. Oh, okay, 2-methyl. Now we've got a side chain. Butane. Imagine your butane with your methyl. It would have been C5, but now it's gonna be C4 because the other carbon went ahead to become some type of side chain or something. 2-methyl butane 1-ol. Can this be a secondary or tertiary alcohol? Let's see. 2-methyl butane 1-ol. Okay, no, this is definitely primary because the carbon that is bonded with the OH is only bonded to one other carbon, nothing else. Okay. Otherwise, if it was 2-ol, then you're gonna say, okay, yeah, this is secondary. But if it was something like 2-methyl butane 2-ol, because that second carbon is bonded to 3 other carbons due to the side chain, I'm gonna say it's tertiary. Okay. Concentrated sodium hydroxide. And remember what I said, when it's concentrated, we are eliminating something here. We are eliminating something here. Oh, 4.1, 4.2 is, yes, please answer that question. We said it's primary because your alcohol is bonded to, your hydroxide is bonded to an alcohol that is only bonded to one other carbon. No, your hydroxide is bonded to a carbon that is only bonded to one other carbon. Yes. Give a reason. Oh, you gave a reason. Okay, write down the structural formula. Go ahead. The type of reaction here is going to be elimination reaction. Okay, we are eliminating something here. Definitely, we are eliminating something here. We must be eliminating something there because they're even giving you a clue. I will show you where the clue is, but we are eliminating. The reason why is because of the word concentrated. You're going to find concentrated and dilute. Go to any other past paper where you'll find this. You'll find these two. I don't know what's happening with this mouse. I'm not going to look for another one, please. You can see what I'm talking about. Concentrated, elimination. Okay, fine. Think about it. Where's this thing coming from now? Please don't interrupt us. Just leave. Yeah. Compound Q. When it's elimination, you can remove hydrogen. It's possible. Remove bromide for me, please, in your C5H11Br. When you remove bromide, you're going to remain with CH2 there at the end. Remove for me a hydrogen, because that CH2 there, this is not substitution. Remember, I said this is elimination because of the word concentrated. So elimination, we are not going to add. This is your dehydrohalogenation. The reason why is because if you remove bromide, that carbon is going to have to bond with something else. Okay, it's going to have to bond with something else. So you've got your CH2 on carbon number 1, CH2 on carbon number 2, which is the carbon next to the carbon that was bonded to the bromide, right? And the first carbon now, right now, if you're doing a structural formula, it must be remaining with the stand, something to bond with, right? Yeah, let me draw it for you. Let me draw it for you, because I know you will say, now I'm confused. What's happening here? CH3, you can see your 3 carbons. Another C, 1, 2, 3, 4, 5. Br, right? This is what we are talking about, right? Now check something here. This carbon was bonded to Br, your H there at the top, and everywhere else there's your CH3 there, CH2, CH2, right? Now you remove this bromide. When you remove this bromide, you will remain with this stand, which is supposed to bond with something else, right? Watch what's gonna happen right now. It's supposed to bond with something else. You wanna try and remove this one, but you can't because what are you gonna put there? You if it was this one, dilute. Yeah, you're gonna remove bromide and say, okay, no, your OH is the one that's gonna go there. Your bromide can bond with your Na, as we explained earlier on. But now this is concentrated, so we are eliminating. No substitution is gonna take place. Okay. When you remove this one, it has a stand. This stand can bond with anything else. Now, I know this is CH2, but you just eliminate it from it. Don't eliminate from it again. Don't eliminate. Let's look for other carbons here. You're going to look for a carbon with less hydrogens attached to it. This is CH3, so definitely you can't eliminate hydrogen from CH3. This is your first carbon. This is also carbon number. This can be, it has potential to be carbon number 1. Now that there's no Br, this can count as carbon number 1 as well. It has 3 hydrogens attached to it, so we're not going to touch it. We're not going to touch this one because it's far away from that one. We are trying to find a space for this one. This carbon, this bond here, this space, this stand, whatever you call it, it wants to bond with something else. So why not remove the hydrogen from this carbon that is bonded to 2 hydrogens? And yes, it is bonded to the least number of hydrogens because every other carbon is bonded to 2 hydrogens except this one. You see, that's why I said this one, you're not going to touch it. We're going to consider these ones. The second carbon, our second carbon is bonded to 2 hydrogens, remove 1 hydrogen. You just removed hydrogen. Your sodium is now going to become a sodium bromide because of the bromide you removed. Your OH can bond with that hydrogen and form your H2Os. This then will still remain there with the hydrogen. This one and the one here is going to bond. These two are going to bond. And then you're going to have your alkene. And because it's an alkene, this is going to be your first carbon. So you're going to have your butene. No, pentene. But this is your pent 1E. You see what I was talking about, right? And I hope you visualize these things because in a test, we don't have time to draw these things. Oh, but they actually asked you to draw one of them. Okay, what am I saying? But you may not have time. Okay, just act like you don't have time. Okay. Name the type of reaction. Okay, we said it's elimination. To which homologous series does compound Q belong? It belongs to alkenes. Yes, it belongs to alkenes because, we removed and whatnot. And we didn't substitute or anything like that. I know you want to substitute, but in this case, we didn't substitute. Okay, let's talk about HBr now. HBr, this is halogen and bromide, right? Let's think about it. Let's think about it. Let's think about it. Let's think about it. Uh, compound Q is your alkene because of the issue of concentrated, right? HBr, first thing first, does hydrolysis take place? Ask yourself that one question. No, it doesn't take place. You know why? Because there's no OH. That's HBr. Okay, fine. Okay, it doesn't take place. Fine. Your HBr bonds there, I mean, is reacting there. You cannot remove because if you remove, it's going to become an alkyne. That's if you remove your H2 from compound Q. So no. But the question is, can we add HBr? And yes, we can add HBr. Your hydrogen is going to go to the carbon with the most hydrogens attached to it, which is probably a CH2 or something, some way, Markov-Nikov. And then your Br is going to go to that other carbon, which is, yeah. Then your compound R, they might ask you what's the name of it. What did you say this was? This was your pentene, right? So this one is going to be 2-bromo pentane, you see, and things like that. Yes, I want to try and find out what questions they are asking. Let me try this. Let me try and find out what questions, what the other questions are. Yes. Choose from addition. Okay, name the type of reaction. Okay, we did say it's addition because we are adding, we can't remove. Write down the IUPAC name of compound R. I just told you the IUPAC name of it is going to be 2-bromo pentene, right? And things like that. Okay, let's go through it. Then you've got this one, butene, compound A, compound B, and whatnot. Let's see. can be prepared from butene by three-step process. Using condensed, write down the balanced equation for step 1, indicate the reaction condition with the arrow. They are trying to look for 1,2 dibromobutane. So here they're going to add a hydrogen bromide, but you know, you want to, this butene, you want to add hydrogen here there so that you can have your butane. Then you want to remove hydrogen here so that you can have your butene again. You see what's happening now? But2e, if you add hydrogen as H2, you're going to have your butane here. If you remove hydrogen, remember the pure must get purer. So if you add hydrogen, it's going to go, now it's going to be a butane, right? Now butane, you want to remove hydrogen, you're going to remove the pure must get purer. So you're going to remove somewhere, somehow you must get a butene from here. Yeah, butene. So that then your no, this is dibromopropane. Propane from butene. Okay, for compound B. Then use to write down the balanced equation for step 3. I will show you the answer. You will work it out and things like that. Just going through the question paper. Let's see what else we have. This one, matrix. If you want more videos on these, this one I will make on another video and things like that. You know, and things like that. Yeah, because remember, I'm just trying to apply the reactions here. That's all I'm doing. I'm not even thinking hard on this because this is not part of, yeah, I don't have to think hard. Go ahead and think hard on it. The IUPAC name for compound B, go and think hard on it. Ask yourself, why does it become dibromo and then propane all of a sudden, you know, from butene? Like what happened to the other carbon and things like that? You know, go think hard on it. I know it can be butane, and then butane, you can add your, I mean, butene, butene, you can add your bromide there, it's possible. Then you're gonna have you 2,3 or 1,2 dibromo butane, you know. So yeah, go and think hard on it because yeah. And that's it with your organic reactions. Remember, dilute, concentrated. Concentrated means elimination, dilute means substitution. Okay, remember those two because this is, and then when you see OH, it means hydrolysis. If there's no OH like here, it's not a hydrolysis. Okay. Mm. Another thing, remember your type of reactions. I hope you wrote those notes down. Let's just go through this quickly. Let's go through this thing quickly. Hmm. Oh, okay. I see what's happening now. Let's go through this thing quickly. Let's go through this thing quickly. You've got your names and all that. You've got your functional groups. You've got, this is what it must look like. Write this down, please. Reactions and whatnot. Your type of reactions, and then you've got your substitution reaction. Okay. Yes. Let's see something. Let's see something. How long? Let's talk about esterification. Okay, let's talk about esterification. Let me just do this on the whiteboard. Hmm. This thing is a problem. Let's talk about esterification. Now you've got your C, then maybe your C. Mm, you know, double bond, oxygen. Let's see which one looks better. This one definitely looks better, right? Then your O, H, right? you've got your three things there and things like that. Then you say, okay, plus, let's talk about your, that was your carboxylic acid, right? Your alcohol, you've got your C, then you've got your COH, right? This is your alcohol and your carboxylic acid combined, right? Things like that. As you can see, you've got your COOH and you've got your COH. So what's happening is that now your ethyl, your alkyl, like ethyl, ethanol weight and all that, your alkyl must be the one, is the one that joins with the O8 part. You get what I'm saying? So the alcohol. So in this case, your alcohol here has got your I mean CCOH. This is your, CH3COH, and this is your CH3CH2OH. This is your ethanol, right? I'm not gonna draw the hydrogens, but please don't forget them, right? Fine. This OH from alcohol, we're gonna remove only the H. This side, we're gonna remove OH. You see, so we're gonna remove we're trying to remove water. So where you have your carboxylic acid, you remove OH. Then over here, you're only gonna remove your H, such that this is your oxygen and your oxygen either way. So your final product would be something like this. You've got your C, and then you've got your O, right? Then over here, you've got two C's again. So write them down, C, C. Then you've got your final H. You see what's happening here? Uh, this is what's happening now. This is what's happening. Out of your alcohol, you removed the entire OH, right? This is out of your alcohol. You remove the entire OH. Then you're remaining with your ethane, right? Then out of your carboxylic acid, you only remove the H. Then you remained with, so out of the carboxylic acid, only remove the H. Then here you remove the OH. Then here you remain with CCOO. That's it. Then there's CCOO, and then your alkyl, which is your alcohol, CH2CH. This is your ethyl ethanoate. Ethyl from your alcohol, ethanoate from your carboxylic acid, ethanoic acid, plus the H2O, because remember at the end of the day, we want to have something like plus H2O at the end of our equation, because this is esterification. This is esterification. Plus your H2O. And then you do want to try and add water again here, but you can't because there are no double bonds or single bonds or anything like that to your ester. You may just have to break it down into your alcohol and your carboxylic acid. They are going to ask you which alcohol and which carboxylic acid was used. Remember, the side of your chain, whatnot, that has a carbonyl. You see, like this one, CO here, COO. This side is the one that represents your carboxylic acid, because COO is your carboxylic acid. Remember when you added R there and you said anything can go there? This one is the one that represents your carboxylic acid. And then the one that doesn't have it, like this part, represents your alcohol. The number of carbons in it represent the number of carbons that were in your alcohol. So you can have something like methyl, ethanoate, octyl, whatnot. Okay. Yeah, all right. That's it with your organic reactions. Matrix, please don't struggle in my presence. If you say you want me to make other videos and things like that, more on these ones, the comment section is yours. Just request the video, okay? Say, I didn't understand this part, you explained it, but I still don't understand. Don't be afraid, just say, can you explain this one a little bit more better or something? Ask your questions there in your comment section. Ask your questions in the comment section. Request videos. Okay, tell me more. What do you want? Tell me what you need help with. someone requested this video. I thought, okay, let me go ahead and make a video and things like that, explaining this thing better. If there's something else that you say you don't understand, ask and things like that. Mm, request in the comment section. Okay, whatever you need. I also give lessons online like this. There you can ask me questions like one-on-one to say, okay, but here, what do you mean by this? And I will answer you and things like that. I will type my email in the description, then so that I can tell you how we go about the lessons and things like that. Uh, this is for like 120 Rand for like 2 hours. Yeah, 2 hours. Okay, and things like that. Then I come and explain everything in full detail and things like that. So yep. Please, don't share with your friends and whatnot. Let them have better understanding as well. Thank you.